All right, guys, we are now going to move on and learn how to write linear inequalities from word problems. Now, we've already written equations from word problems, and now we're going to use a similar strategy to do it with the inequalities. There are going to be some phrases that you want to make sure you jot down because when we're looking at inequalities, you're going to hear such things as A is more than B, or something is at least B, or A is less than B, A is at most B, or A is no more than B. And you can see the inequality that corresponds to some of these phrases here. All right, the ones that tend to be a little tricky are going to be the ones where it's at least, at most, and no more than. So let's just try and jot these down, make sure we have these written, so you can always refer back to them as we are looking at the equations, as we're looking at the problems that we're trying to solve here. So here's our example that we're going to start with. Okay, it says an 18-wheel truck stops at a weigh station before passing over a bridge. The weight limit on the bridge is 65,000 pounds. The cab, which is the front of the truck, weighs 20,000 pounds. And the trailer, which is the back portion of the truck, weighs 12,000 pounds when empty. So in pounds, how much cargo can the truck carry and still be allowed to cross the bridge? All right, so we need to look at some of the key information within this word problem to then be able to create a linear inequality from it. So some things that we want to look at and focus on are going to be the weight limit, which is 65,000 pounds. So if there's a weight limit, that means it can't go past that. Then we also have information about the cab or the front of the truck, which is 20,000 pounds. And we know about the trailer, which is the back portion, which is 12,000 pounds. Okay, ultimately, the question is, how much cargo can the truck carry and still be allowed to cross the bridge? So we're trying to figure out up to what amount can it still hold to be able to cross, given these conditions here. So if we try to break this down into an inequality here, we're looking at, we know the very highest amount, the upper limit, is going to be 65,000 pounds. So now we're trying to figure out, well, what is the range of possible answers for the cargo? Because remember, we're going to have different answers that could satisfy the inequality. And so we're putting a scenario together for ourselves to figure out, well, what is that maximum amount that could potentially be in that cargo? So we take the weight of the cab, which we know is 20,000, and we're going to add that to the weight of the trailer, which is 12,000. And then we can add that to the cargo weight, which we don't know what that is. So we're going to allow C to be the weight of the truck's cargo. So when we add these three components together here, these three terms added together should not be more than 65,000. But it can be equal to it. It just can't be greater than it. So it has to be less than or equal to 65,000. Okay, 65,000 is the maximum it can be. So now we can take all of this and actually solve the inequality to be able to figure out what that would be. So we can add our 20,000 and 12,000, and that's going to give us 32,000. So we can subtract 32,000 then from both sides of the inequality, which then leaves us with C is less than or equal to 33,000. And that's 33,000 pounds. So the cargo that we're allowed to have can be up to 33,000 pounds, but nothing more than that. Now, a second example here. Okay, this second example, we have, it says, Erica has found 3 pairs of running sneakers that she likes. costing $150, $159, and $179. She has saved $31 already, and she has a job where she earns $8.50 per hour. The question is, how many hours will she have to work in order to afford any of these sneakers? Okay, so again, there's some information, key information that we would want to look at and pay attention to, and most importantly, understand the question that's being asked. Again, it's asking us how many hours she's going to work in order to afford any of these sneakers. So we don't know which one that she's looking at, but we do know the different potential prices that are there, right? So we have $150 for one. She's already saved $31 because $150 is for the smallest amount that she would need to be able to obtain one. Okay, and then she's already saved $31, and then she earns $8.50 per hour. Okay, so in this situation, because again we don't know which one of them, it just says how long would she have to work to just obtain any of those sneakers. That's why we picked the cheapest one. So we picked the $150 ones because we have to get at least that amount. And all the other ones are actually greater than that. So the smallest possible number or amount that we need to get is going to be $150. So to create the inequality here, we're going to go ahead and look at first starting with her hourly wage, which is $8.50. Okay. We're trying to figure out the number of hours she's going to need to work, so we can call that H. So $8.50 times H. And then she's already saved $31. So then we can add the $31. Now this left-hand side of the inequality needs to be at least $150, or it can be greater than that. So it can be greater than or equal to $150. Because if it's greater than $150, she can get any of the other sneakers that she would want. So that's why we have to figure out what is it that she would have to work to at least be able to afford the $150 ones. So now we can go ahead and solve this as we would normally. So we have 8.5h plus 31, which is greater than or equal to 150. Okay, subtract our 31 from both sides. And then finally, divide both sides by 8.5. And we find out that the minimum number of hours would be 14 hours. So anything past 14 hours, she would then be able to afford any of the sneakers that she wants. So Erica needs to work at least 14 hours to afford any of the running sneakers. If she works more hours, she'll be able to afford the more expensive models. And there you have it. So these are two examples of how we can write linear inequalities from word problems and then go ahead and solve them to figure out the restrictions that are put in place. So it's your turn. Go ahead and do some practice and get yourselves used to writing inequalities from word problems.